Good afternoon, everyone. Today is April 16th, and this is the HamSCI Telecon. So I'm Nathaniel, W2NAF, and I'd like to welcome everybody. We don't have a particular agenda today, I think. We'll go through a list. Everyone can make a comment or two, and then we'll see if anyone has anything they want to discuss with the group. They're more than welcome to. One item I do have, you may have seen it go out to the listserv. I made a presentation that covers basically what the status is of the personal space weather station. And I have like one summary slide kind of for each team or each part of the project. And so if you have any updates or corrections to that, I'd be very interested to hear that. One of the motivations for that is right after this telecon, I'm supposed to give a presentation to the engineering group over at Penn State, and I'm supposed to tell them about our project. So I wanted to make sure I had good information for them. And some of the people who are at Penn State, they are, they've been around the CDAR and ionospheric science communities for a while. So they're definitely going to know what to look for and what questions to ask. So we're getting ready for that. So that's about it from here. So see, I guess I'll go start at what's currently the top of my list. One of the challenges with the Zoom lists is that as people talk, the names rearrange themselves. So if I miss someone at the end, just let me know and you can go ahead and give comments. But I'll start off with the first person on the top of my list, and that's Bob Gerzoff. Go ahead, Bob.
Hey, Nathaniel. Hey, everybody. Can you hear me?
Yes, we can.
Hey, good. Just hello. Hope everybody is safe and healthy. And I'm just trying to figure out, I know if there has been any further progress on looking at VOA cap. As I go through the readings, it seems to me that the new VOA prop is basically the new edition of VOA cap, and that they are one and the same, using the same prediction model. So if anybody has any comments, and my application here would be to sort of generate a file of predictions, so that I could do sort of I almost hate to say it, an epi approach towards the successive probability of communications. Just be curious if anybody has done anything like that with VOA prop. And back to you, Nathaniel.
Thanks, Bob. Really quick question. When you say VOA prop as opposed to VOA cap, what do you mean?
There's that new program that's $200. Is it, maybe I'm having a senior moment. What's the name of that program that's $200 and it does the 3D models of propagation, and the engine underneath it is supposed to be the same as VOA cap, if I understand things correctly.
Are you talking about PropLab Pro?
Thank you. Sorry.
Okay. So actually, I can tell you for sure that almost 100% assurance, and Carl should be able to update me. PropLab Pro is not running VOA cap.
It's not.
No. So PropLab Pro should be running for its underlying ionospheric model, the IRI 2007. That's the International Reference Ionosphere 2007. And what it does is that serves as, here's a link to where you can actually run IRI kind of in real time and IRI. So I'm putting some IRI links in the chat window here. IRI model. So what IRI is, it's just a model, an empirical model of electron densities. It should be correct in a monthly median sense, and it should, it's obtained its data from, I think, ionosons, from incoherent scatter radars, some in situ measurements over a number of years. And it does not actually do any radio propagation predictions. What PropLab Pro does is it takes those ionospheric electron density predictions and it uses ray tracing. So you're actually able to calculate a index of refraction as a function of electron density and the Earth's magnetic field, and you're able to predict using geometric ray tracing where the radio waves go. And so that's the basic concept behind PropLab Pro.
All right, maybe I was thinking VOA Prop because I'm looking, well, maybe I was getting it mixed up with something else. Well, just carry on, and I'm going to do some double checking, and if I need to double check in with you later, I will do that.
Sounds good. Okay, so next, I'd like to welcome Dev Joshi, Dr. Dev Joshi. So as I said on the listserv the other day, Dev is now joining us as a postdoctoral research associate. He will be working here at Scranton. He's still actually working at Boston College for the moment, but he's starting to work for us, and he will be transitioning over to Scranton within the next few months. And his job is to work on developing the scientific analysis portion of the Tangerine SDR for the Personal Space Weather Station project. So Deb, why don't you introduce yourself and say hello?
Hello, everybody. I think I've been already briefly introduced. Once again, I'm Dev Joshi. I recently finished my PhD at Boston College under the supervision of Dr. Keith Groves. I worked in equatorial ionospheric research, analyzed data from a sounding rocket experiment and a satellite mission in which I looked at the irregularities, equatorial ionospheric irregularities. And I made some analysis. I have published a paper, and I'm writing a few more papers, which I expect to publish in future. And I look forward to connecting to this exciting group here and learn more and try to contribute in any way I could.
Thank you very much, Dev. I appreciate that.
Thank you.
You're welcome. So we're looking forward to having you do more work with us. All right. Aiden, go ahead. Aiden Montari, do you have any comments for the group?
Aiden, you're on mute.
Sorry, I was muted. Thanks. Let's see. So I'm Aiden Monter. I am from Case Western, though currently home in Eastern Pennsylvania. And I don't know, I've mostly been working on automatic uploads to Zenodo as our sort of in-between storage mechanism right now. And so I've been enjoying working with the data processing and data uploading and data downloading and all those things. And I'm hoping to head downstairs with my dad and play around with our ham station and get some things working sometime this evening or in the coming weeks, because it's fun to actually play with stuff. So that's all from here.
Thanks a lot, Aiden. Sounds great. Bill Engelke, AB4EJ, go ahead.
Well, anybody who, I think most of this group is probably following the Tangerine SDR mailing list. You've seen the past few days, I've been working a little bit with Scotty and Tom, trying to figure out how to set up channels for this first iteration of the Tangerine SDR. And this is a good question to pose for the scientific community to consider. We can cover it under general discussion when we come to that, rather than trying to go through it here. But dealing with the frequency of sampling, the bandwidth, the frequencies that we're going to collect, and how to actually command the data engine to do that in such a way that we can make multiple use of the data. We could store it in digital RF, or we could also run an FFT on it and extract information around carrier frequencies. And so anyway, what I want to do is I want to select a first approach on how to do that, put it into the simulator and that I'm working on. And then at the same time, Scotty and his team can be setting up a first pass on the FPGA code so that it will respond to those requests coming from the small board computer and give back what we expect coming into the SBC side of the Tangerine. So I think we're probably pretty close to being able to do some work on that. It seems like if we're pretty close to having a radio and having a prototype. So anyway, that's what I've been working on. And if you've been reading my posts in the Tangerine mailing list, you're probably pretty much up to speed on where I am on that. So back to you, Nathaniel.
Thanks, Bill. That sounds great. Yeah, I think we'll try and come back to that during the general discussion. Carl, go ahead.
Oh, okay. Hello to everyone. We've had some, yesterday we had about a half an inch of snow and it melted, and then we had some more snow and it melted. So we're going up and down, that's for sure. On the WWV to WA5 FRF front, Steve sent me his, the easy neck model of his antenna, and looking at that path, at least for one of the modes at a given time, it doesn't look like there's any issues with polarization. His antenna has both horizontal and vertical components, which I think helps a lot. So I'm not sure how much farther I'm going to carry that. On the TIDS research using the RBN network, I did get a reply from NOAA, and they do have old data from January 26, 2017, which is one of the days that Diego identified as, hey, there looks like the RBN network shows maybe there's some TIDS going on. So the only problem is it's in area format, which I'm not familiar with at all. I wonder if anybody has a little bit of knowledge of that. Maybe can help, you know, how do I open these files and all that kind of stuff. I also sent some pictures to Christina because she asked for ham radio pictures. So hopefully I helped her out if she used them. And that's about it, Nathaniel.
That sounds good, Carl. When you say area format, is that what you said?
Yeah, that's what they call it, area format, which, you know, I can go on the web and, you know, Google that, and it still doesn't help me understand what it is.
Maybe if you can send me a sample data file, maybe I might have an idea.
I will do that.
I'm not familiar. It doesn't sound familiar to me, but send me a data file and I'll take a look and see if I recognize it.
Yeah. You know, what the GOES satellites do is, you know, that you can go online and look at a movie of what's happened for, you know, many hours of the day, the current day. And somehow they archive that. I don't know. I don't think it's a movie anymore. It might just be still photos every several minutes or something. I'm not sure what it is. You know, I tried to open stuff with, you know, JPEG and all that stuff, and man, nothing happened.
Yeah.
So I will do that, Nathaniel. Thank you.
Okay. Yeah, I'll take a look at that. Okay, great. So next we have David Kasden. Go ahead.
There we go. Hi, greetings everyone. I'll turn the camera back on. Mostly I'm going to defer to Christina and to John Gibbons for what we have going on. But the WWV monitoring continues apace. We're collecting data. I want to congratulate both of them on getting our first receiver out into the wild. We have one in the hands of a high school senior and her father. They're the first ones experimenting with John's circuit board and our software and actually collecting data. And they, in fact, have collected several days of WWV carrier frequency Doppler shift at this point. Some bugs to be worked out, but I think that's most of my news, and I will defer to the others.
Thank you. Yeah, that's really good news. I'm glad you got that out to the Bontes. I wasn't aware that you were going to do that, but I am super, super excited that you were able to do that. I'm super glad the Bontes are able to continue participating. That sounds great. Why don't we hear from Christina next?
Hey folks, so we had a meeting earlier this morning. We've started doing a weekly telecon at 10 a.m. specific to the WWV project, and especially the Doppler shift work, but then also other ways of extracting information from WWV. And Bill, we want to invite you specifically to next week's if you're not busy, because we're right at the point where we're talking about setting up the metadata and figuring out how to get the uploads working in the data archive. So that's a longer discussion that we're currently in the process of. I've got my station over there running and collecting Doppler shift data right now. And as Aidan mentioned, sort of our next step is figuring out the data uploads to Zenodo as an initial way of setting up our getting used to putting things into a database before we start integrating things with you guys. So that's sort of the main thing that's going on, is we're just continuing to move that project forward. And then quick note to Nathaniel, we talked earlier about possibly putting in a proposal for the AGU fall meeting, if in fact there is an AGU fall meeting. And there's a couple of different things that look like that might be able to fit, but basically we should put in about 300-word description by April 23rd. So I'll send you an email with some notions for that.
Okay, thank you, Christina. That sounds wonderful. Thank you very much. And John Gibbons, go ahead.
Yes, actually this past week I got quite a bit done. I actually disseminated 4 weather stations, one to David, which is running his, I believe it's 2.5 megahertz data collection. Got one to Christina. I got one down to the Bontes in Columbus, and I set up a second one here in my home QTH with 2.5, so I'm actually collecting now 2.5 and 5 megahertz Doppler shift data. I'm experiencing some system crashes on the Raspberry Pi, and I think we're running into a memory resource issue. And I just found out that David and Christine were running a VNC session while the thing was trying to process, which is probably the kiss of death. So
I was not running a VNC session.
I know David, I believe, was.
Okay.
But
VNC's installed, but I haven't run it on mine.
Right. Now, both of mine have been running fine, and I haven't had any crashes, but I specifically get out of doing anything that takes up memory. But anyway, that's another story for another time. We discussed some progress moving forward on data formats, which will indirectly down the road affect Bill, which we're going to want his input on. Nathaniel's suggestion for making my 4 radio next gen receiver create 4 separate files, I think is a really good idea. That way it modularizes everything. We also were talking about modularizing the magnetometer data and possibly temperature data. We don't know if we should link those together. Scotty might have some input on that. And before Scotty disappears, I want to get a part number from him for what he's using for the extender for the I2C bus for the magnetometer. That's all I've got to report.
Thank you very much. I appreciate that. Scotty, why don't you go ahead next?
Let's see, I guess I'm on now. Yeah, okay. I can get you that information there, John. I have to look it up on get you the full part number. I'll post it in the chat window there. Been mostly working on some other projects that were surreptitiously putting in SDR features, but I won't go into that. We did get the RF board completed, John and I and our CAD guy. We got all of the notices put on it. We got all the cleanup done. And I think unless we find something that's incompatible with the data engine, as far as size goes, I think we're done with the RF board. So that's a good milestone to tick off and check off and be ready to now actually while we're finishing up the data engine, we're going to be working on the manufacturing and prototyping of the RF board. So we're going to be getting the bill of material in order and trying to do some costing of quantities, so we get an idea of, well, what is it going to cost when we go into production of this? How much more is it? Looking right now like it's going to be more expensive than the data engine, which is kind of weird, but it's expensive A to Ds on it, so that's what's driving the cost up. But when we start building quantities, it's going to bring the cost down, so that's going to help a little bit. And then Dave, KD0EAG, has Dave Witten has given me all the data on the magnetometer, and I'm thinking that I'm going to want to productize that coming up pretty soon after I finish the DE. So we're going to have a lot of things in the pipe here coming up, but I think we're going to start seeing hardware pretty quick. So I guess that's back to you, Nathaniel.
Thanks, Scotty. A question, since I'm a little new to this whole hardware design and production. When you say the RF board is completed, what exactly does that mean? You have the schematics done and the actual like layout completed?
Yes, we have the Gerber files done. So we have the official BOM. We have the board completely laid out. It's all routed, and it's ready for manufacturing.
So you just pick a place that you want to build this thing, you send them Gerber files, and you pay them a bunch of money and say go?
Well, yeah, almost that easy. Because for prototyping, we buy the parts because we want to make sure we get the right parts, and it's at this point we're still kind of double checking the BOM because it's never been built before. So double checking, and we'll find some errors, I'm sure, of a 10 nanofarad cap that the part number is 100 nanofarad, or it'll be some silly thing like that we'll have to fix. Mm-hmm. And we'll go ahead and buy the parts to do that, to build the boards. And then when we get that done and we know that all the corrections have been made to the BOM, then what we'll do is we'll buy whatever the minimum quantity of PC boards is for the minimum order. So it'll typically be, and it's kind of ridiculous, but it'll typically be about $2,500 for PC boards. And I know everybody says, oh, I can get PC boards for $5 each. Well, these are 4-layer impedance controlled larger boards. And so we go to an official board shop. We will go to a cheaper board shop when we build them in quantity. But for the prototypes, we don't want any problems with the board layout. So we'll pay a minimum quantity, and we'll get however many boards we can get for that minimum amount, between $1,500 and $2,500. Mm-hmm. And then we'll build one using the parts, and it'll be built by hand, but it'll be reflowed. So we have a local shop here they'll hand place the parts, and they'll program their machine at the same time, so that, but we don't want to wait for the machine to be programmed to run it through the reflow machine. So we'll get the board reflowed so it'll be professionally built, and then we'll check it. And once everything checks all out and we've determined we didn't make any mistakes on the bill of materials or any mistakes on the schematic, and the board is good, then we can go and either we'll go and have the remaining 5 or however many that we're going to build, have them automatically built at our local contract manufacturer here. And then we'll have the prototype quantities to pass out to everyone. Now, after we do that, then we're ready to do what you had said, is give it to the contract manufacturer. And typically we like the CM to buy the parts, because typically they can get better prices than we can, especially on things like resistors and capacitors. It's ridiculous for us to buy them and send them to someone when they can just buy them direct and save money. So we'll negotiate with them, and we have at least 2 different ones that we deal with, one domestic one and one foreign one. And it's not in China. So, but with this worldwide pandemic going on, it remains to be seen how that's going to affect things. It probably will end up slowing things down, but not as much as you think, because assuming that they're in a country, they're in Hungary is the place that we use. Assuming that they're not all shut down, then we don't really interact with them on a physical level. So if they're open for business and they're running their factory, then we can get boards in a reasonable amount of time.
Do these boards have VGAs on them?
Yes, they have the RF board does not. It has a QFN.
Okay.
But the DE has a 672 pin BGA, so it's And there's several other other smaller BGAs on it too. So it's going to be a challenge to build.
Yeah, that's tricky. You have to have X-ray equipment to really inspect those correctly.
Yes, and the idea is that when we go to contract manufacturing and we say, okay, give me 500, we are going to provide them with a manufacturing test fixture and a procedure to go through, because if I don't do that, what happens is they'll send me 500 of them, and then maybe 400 of them will work.
Maybe.
Depends. And especially the first ones out, you have
Yep.
a less of a chance of getting them all working. So what we do is we say, okay, here, manufacturer, here is a test that's, and typically it'll be a loop back, and not really a functional test, but it'll be a test of every data path on the board. And we can get, with loop back plugs, we can get pretty much 100% coverage. And so okay, you plug it in, you run the test. If the red light comes on, I don't want to see that board. You fix it. There's a problem with it. And again, we're not fixing design problems. We're fixing connectivity problems, like you didn't get it soldered down right. The BGA has an open pad underneath or something. So it really helps us, because then we don't have to pay for a board that doesn't work. Because I don't have the equipment to fix BGA type problems, but they do.
It's worth every penny.
It's worth every penny.
Yeah,
and
been there, done that.
And the price will be a little higher, but it'll only be a little higher and not a lot higher. And after going through the HPSDR project, where we basically got 100% of the boards working, but the last 2% was excruciating, because we had to hand debug everyone and find them at the open circuits, open solder joints or shorts or whatever it was that we found that was the problem. And it was very few boards, but they took a long time to do. So I'd prefer to not do that. I prefer to let the manufacturer figure out his process problems and do what he does best.
Mm-hmm. That sounds really good, Scotty. So do you have some idea of when we would have a totally working or usable Tangerine SDR, including a RF board and clock module? Do we have an approximate date for that?
The clock module, I don't really have a date for, because John and company are still working on it. We've kind of tentatively assigned the pinout, and that pinout may be subject to change depending on the layout on the data engine, because the layout on the clock module is going to be much simpler. So we're going to let the data engine dictate what the actual pinout is for running purposes. We did a lot of that on the RF module, because the RF module is pretty complex as far as length matching and all that on all the data lines from the ADCs. So we swapped a lot of pins around on the connector between the DE and the RF module, and then we fix that, and then we'll route the data engine to match that. Same thing's going to go on with the clock module. So the clock module is going to be last. However, the good news is we can run the data engine and the RF board without the clock module. We may not get the performance that we need for the Space Weather Station right out of the gate, but we'll at least have something that we can debug the RF module and the rest of the DE hardware with.
Yeah, that'll be really good.
Yeah,
and we can also start developing some of the software protocols and start working out some data format issues, even without the clock module.
Well, and I want to work with Dave, KV0S, on the programming of the board. And as soon as I finish the hardware, and we're working on the layout, and then of course we've got build time. We've got to wait for parts to arrive. We've got to wait for PC boards to arrive. Dave and I can work on the programming, because the whole goal is to be able to upgrade the firmware seamlessly, easily. Anybody should be able to do it with a very simple program. You shouldn't have to load 3 gigabytes of Quartus tools and fight with those to try to figure out how to update the firmware in the FPGA. I want to make this really simple, because we're going to be doing it a lot.
Right.
Let's make it really easy.
That sounds really good. Okay, so but out of that, so do we have a month? Like, if I told people, September, do you think we'd have some hardware by September, maybe?
Yeah, because the goal really was to have a working radio by DCC. So, and that I think will still be the goal. And we might actually be able to do it a little bit faster now that there's not a lot of other competing things in the way. All the in-person stuff's been canceled.
Yeah, that sounds good. So that sounds good. And then I think that all sounds fine, Scotty. And maybe I can talk with you a little bit more later off of this about just some more of the logistics and the financial considerations to make sure that everything is in line that needs to be in line.
Yeah,
Yeah.
especially the request that we looked at a few weeks ago.
Yes, yeah. So we should talk about all of that.
Yeah, I don't want to talk about it on here until it's more, we can make it more public.
Yes, sounds good. All right, that sounds great. Thank you very much, Scotty. So how about Dave McGaw? Go ahead.
Hello, everyone. Yeah, a lot of things going on here, not the least of which is I just noticed that our ground had turned white. Just got a snow squall go through here. But I'm working on a bunch of things, filling out our AM Doppler project. I've got, I'm also working on a sounding rocket that involves radio propagation, in particular VLF. So I'm working on a 3-coil loop antenna for picking up NAA from our location, using that, getting propagation information from there. And I haven't seen any email traffic lately on the Tangerine SDR magnetometer. And I wanted to know what the status of that was, because I've got a couple of the magnetometer boards already, and would like to be able to evaluate them through the magnetometer project, if that's possible.
That sounds good, David. I think the magnetometer situation is actually in pretty good order from what Scotty and Dave Witten tells me. So if you want to do some of that directly, you might want to email Scotty and Dave Witten and communicate with them directly.
Yeah, okay.
Yeah, I'd like to be included in that loop as well, because I just got 10 of them myself.
Yeah, or just put your request out on the Tangerine SDR list. So
okay.
Yeah, that would be fine. You can communicate that way. Okay,
Yep.
Great.
Good idea.
All right. Let's hear from Diego.
Hello, everyone. Hope everyone's doing well. So yeah, I'm still working with Nathaniel on his ham radio TID search. I unfortunately haven't had too much time these last couple of weeks to really work on the project due to a couple COVID scares. But I am currently trying to get together all of the CanMOS plots to see if substorms was a possible source for the TIDs that we saw in the paper. Yeah, thank you.
That sounds really good, Diego. And by the way, toward the end of today's talk, I know I'm still trying to figure out the best way to run these meetings. And I really like getting updates from everyone, but it takes a long time. And so I think what we should do is maybe do this like every other time or something like that. But one thing I think we should do is would like to get some volunteers, a volunteer or two, to put together a science presentation. So that might be you, Diego, to give us an actual PowerPoint 2 weeks from now on an update. Would you want to do that?
Yeah, absolutely.
Okay.
Absolutely.
So I will put you down, Diego, put together like a 20-minute PowerPoint for 2 weeks from now on progress on your research.
Okay, sounds good.
Scheduled. Okay. So you are looking for substorms.
Yes.
Substorm in CanMOS data as a TID source. Thanks, Diego. That sounds great. Jonathan Rizzo, go ahead. Jonathan, are you there? All right, nothing heard. We might come back to him. Mike Naruda, go ahead.
Greetings to everyone, and welcome, Dev, and glad you could also attend the Tangerine SDR TeamSpeak meeting. I've been listening on the higher HF bands, and for example, on 50 megahertz, I was hearing stations in Florida and Texas. I'm in Michigan, so that was sort of unusual. And last night, 14 megahertz stayed open. I was here in the West Coast. I attribute this to more hams being on the air from the quarantine. Thanks very much. Over.
Thanks a lot, Mike. That sounds great. All right, Steve Kepler, go ahead.
Hi, everybody. I'm Steve Kepler. I'll be brief. I'm an assistant professor at Clemson, so I'm also, my call sign is 80AE. I'm not sure. I sort of pop in and out as I can. But I don't really have anything to report. I mean, Nathaniel and Gareth and I are talking, and Dev. And also, I just want to say a shout out to Dave McGaw, since he knows me from various sounding rocket experiments. So
Yes,
I will
indeed.
turn it back over to Nathaniel.
Thank you very much, Steve. Sounds great. And Steve Serwin, go ahead.
Well, good afternoon, everyone. Gosh, I'm semi-retired, but maybe I should get a full-time job so I get some free time. We've just gotten slammed with project work, and it's been this way for a few weeks and is likely to continue. But anyway, and that's cool. I've got a pretty well-equipped RF lab here in the house. I've been working out of the upstairs of my home for about 15 years, and it's kind of cool to be able to do that. So COVID hadn't slowed us down any at all here. But I did get a little bit of time to look into ways of separating the effects of WWV and WWVH, because both of those come in here at the same time on 5 megahertz. And I've got a little bit of preliminary data. If you want to look at this a little bit later, I can show it to you. But I plan on doing some more of this work and putting it together into a presentation. But in the meantime, it looks like there are ways of separating out those two effects. That's all the news that's fit to print from here.
That sounds great. Let's see, we have about 20 minutes left, and one of the things we wanted to do was hear back from Bill about channels, bandwidth, and that data, but I do want to see some more science. So Steve, maybe do you want to show us a few things that you have right now? And then maybe we have Diego scheduled for giving a presentation at the next Telecon. Maybe should we schedule you for a more formal presentation for the Telecon after that?
Sure.
Okay, that sounds great. So yeah, go ahead, Steve. Why don't you show us what you have going there?
Can I share my screen?
Yes, if I may have to enable that. Yes, you can share your screen now.
Is it there?
There you go.
Okay, so I've been sort of zooming in on things that happen in the morning during the night to dawn transition. Here's a typical plot. Here's nighttime down here. Here's the dawn transition, and here's into daytime. And you see that lots of stuff is going on. In a good spectral waterfall, you can see the fundamental in all these different modes. And we've seen a lot of these come from different propagation modes, like Pedersen rays and multiple hops. But not only that, but I know that both WWV and WWVH from Hawaii come in. So you don't really know what parts of these are from which. And I know that they're coming in because when I listen to it with my ear, I hear both the female and male voice announcements at the same, that one follows the other. So I know they're both coming in.
I had a quick question. Is there any way to get polarization information? Maybe you're using one antenna, but if you use like 2 cross loops or cross dipoles or something, could you actually somehow get polarization out of? Because could you distinguish based on polarization maybe, or get more information?
There is an excellent antenna solution from my location here in Texas, because the angle between Hawaii and Colorado is like 60 degrees.
Okay.
I could use a loop antenna and put a null on the one I didn't want. I could do the same thing with an adcock.
Okay.
Just directional antennas that have deep nulls. Both the loop and the adcock have razor sharp nulls. And I could, without question, null one of the other. You know, people do this all the time on 80 meters to get rid of interference.
And Steve, I'll suggest that if you have enough signal that you're getting audio from both, then instead of looking at the carriers, look at the audio modulation.
Yes, you suggested this before, and that was the next thing I was going to say pursuant to what you mentioned. Here is a recording I made this morning at not listening to the carrier, but to 500 hertz, okay? Now, WWV and WWVH transmit their tones on alternate minutes, you know, even and odd minutes. One time, one of them's on 500 hertz, while the other is on 600 hertz, and then they swap. They go back to 600 hertz and 500 hertz. So, and they're not on all the time because they're interrupted with voice announcements and silent times and other things. But here is listening to 500 hertz through just right after dawn this morning at the bottom, and then up through a little after 9 this morning. So you can see that on even and odd minutes, you see how there's separate, there's gaps and then signal, then gaps. Well, up here, I'm listening to only WWV, and WWVH has already gone by the wayside from delay or absorption. Can't hear it anymore. But down here, you see there are no nulls in between. So down here is when they were both present. But the point, and you can see there's meandering structure in there. One of these is from WWV, the other is from WWVH. So if you put this kind of data side by side with that first type of picture I showed you, you could tell who's making a contribution at one particular frequency. Now, it does get complicated. You can't get as narrow a trace because these signals are not continuous. They're interrupted every single second with a timing tick and then little tones of silence. And when you're doing high resolution DSPs with big bins, bit bins to get high resolution, it tends to average things out. But you can still separate the differences. Here's one on 10 megahertz where I was hearing only WWV. You can see there's pretty much darkness in between these bright bands. So where there's a brightness, that's when WWV from Fort Collins, Colorado is coming in on 500 hertz. And then WWVH is at 600, which you can't see here. And then on the next minute, they swap. And Hawaii would be transmitting on 500 hertz while WWV is on 600, and it just goes away. Except it doesn't completely go away. You see that in between these bright bands, there's still some signal. And where that comes from, WWV transmits a 100 hertz subcarrier in which is encoded actual time of day that can be copied and decoded by some clocks to actually display time of day. They do this with timed amplitude changes. But this low-level subcarrier shows up as a sideband around every AM tone in the entire WWV spectrum, which means that every second, even if it's on 600 hertz, there is a smattering of 500 hertz because you get the plus and minus 100 about the carrier. Let me see if I can say that a little clearer. Even when WWV is at 600 hertz, and I would be expecting to hear something from WWVH in here, because of that 100 hertz subcarrier, it's not only transmitting 600, it's also transmitting 500 and 700. And that 500 is right on top of the place where WWVH would be. So there's still a little bit of interference. But David, you're absolutely right. You can use this stuff to separate the two out. And you can see, for example, the one taken this morning, this data was GPS-DO calibrated. Right down the center line here would be right on frequency, and you can see that indeed they are all shifted on the positive side by maybe up to half a hertz or so, which is commensurate with morning positive shift Doppler. So I intend to do some more work like this. I'm going to record simultaneous recordings of the carrier along with this kind of data so that you could, you know, look at some feature over here and then look at this feature over here and tell which one of these might be from WWV, what would be from WWVH. I also have an FM demodulator, which reports a single frequency average value of what's going on. Its claim to fame is that it updates at 100 times a second. No averaging in big DSP bins. So it can follow frequency pretty much in real time. It's very similar to how FLDigi works in that manner. The advantage, of course, of a spectrogram is that it actually lets you see the different frequencies at the same time and doesn't average them together. So anyway, that's what I've been thinking about doing. I doubt I'll have time to go out and build an Adcock or loop antenna to do the nulling, but I would, plus this is a more general approach. For example, you guys over on the East Coast, the angle between Fort Collins and Hawaii isn't so kind as it is down here.
Yeah.
You have to have a really razor sharp antenna to separate them in that direction. They're almost in line.
And we really also, we need an approach that's very general, that because you're doing this with a single antenna, right?
That's correct.
Yeah, we need an approach like that because we basically, for the personal space weather station application, we have to assume that someone's just going to go stick this box out in their yard, stick a single antenna up, and then we really need to do as much as we can in software with as little hardware configuration as possible.
So basically that's it. You can see when they're both present because there's a signal every minute as opposed to the times when one of them goes away and then you only get a signal every other minute. That subcarrier complicates things because even when it's on the 600 hertz tone frequency, that 100 hertz subcarrier scatters energy into the channel you're listening to. And it's not all the time. There's big places on their normal programming where they don't transmit those tones. But nonetheless, it's there a lot of the time.
Steve, is there any possibility that 100 hertz mixing represents a nonlinearity in the receiver's audio chain?
I thought about that, and I've seen other nonlinearities, a lot of them, like frequency doubling on the time ticks. And that's another area I'm very intensely interested in. But to answer that question directly, I went back to some data, published data that WWV puts out. And in here, they make the statement about this subcarrier that it appears everywhere. It says here, time of day is also continuously transmitted using a digital time code interpretable by radio control clocks. The time code uses a 100 hertz subcarrier of the main signal. That is, it is an additional low-level 100 hertz tone added to the other AM audio signals. So they pretty much tell you that it's going to appear as sidebands about every tone they transmit. And
no, I'm sorry, that's not what they're saying. They're just saying that there's a 100 hertz carrier on it. But,
yes, I agree with that statement.
Yeah, I think the sidebands that you're seeing are intermod, probably more in the receiver than the transmitter.
It could be. This is a, well, it's a single sideband. It's not a nonlinear detector. It's a completely linear modulation chain. Yeah.
Well, you'd have to know something about their transmitter, their AM transmitter, but you know, our receivers are probably more nonlinear than their transmitter.
Possibly.
Nathaniel, could I say something again?
Yeah, please do.
I forgot to mention when I was up that one of the things, another thing that's going on is I'm working with Phil Erickson on his WWV receiver. He was interested in trying out the Mike Trimpey loop type antenna and preamp. So I sent him some parts and such, and hoping he can implement that and give that a try. And one idea there would be to use 2 loops. You could either null one or just null them in software in analysis. But the with multiple loops, you can get either angle of the radiation or azimuth. And anyway, our system, we've used it for 5 to 10 megahertz, as well as VLF to 5 megahertz. The design I sent him is optimized for 5 to 10, but hopefully we'll be able to pick up at least 2.5 to 15. And going to be interested to see what he finds using that system.
That would be something we should talk more about, because especially for a couple reasons. All the reasons you stated, and the Personal Space Weather Station does have the Tangerine SDR one is going to have dual channel input, and we'll be able to take advantage of that. Out of curiosity, how much do you think, you have some ballpark figure for how much it would cost to create a crossed loop HF receive system?
What do you mean? What part of the cost are you thinking?
Well, for the antenna system.
Well, the antennas are dirt cheap. We build them out of either TV mast or PVC.
Mm-hmm.
For the HF loop that we've been doing experiments, and we've had them in Greenland, at IceCat, Norway, and got one currently running down at South Pole. That's 5 to 10 megahertz optimized. It's 5 feet on a side, 1.5 meters, loop of 12 gauge wire. So it's very cheap to implement the antenna, and then the preamps are a couple of chips and a transformer and a bunch of components.
That sounds really good. We'll have to keep talking about that. What do you think, Scotty?
Yeah, and if anybody would like the documentation on this to consider implementing it, I can pass that on.
Yeah, I would like to see that. Sorry, I didn't get unmuted here.
We're hearing you.
It does sound very interesting.
Yeah.
Dave, I actually would too. And I was talking with Jim, and I'd like to actually make a trip up to Dartmouth sometime. I was going to say this summer, but that's probably...
Yeah, we'll see when we're open.
Yeah, so
we're running we're starting to run a little low on time. I want to address a couple other things really quickly. I'm looking ahead at the calendar. We have a Telecon scheduled tentatively for a month from now is May 14th. Now, one of the things that's happening, I'm proposing that we cancel the May 14th HamSCI Telecon, because that day we're going to have a virtual contest university. So every year at Hamvention, the day before Hamvention, Tim Duffy runs a contest university, and there's presentations all day long. And it's now going to be virtual this year. So I'm actually supposed to give the 10 a.m. talk, and I'm going to be talking about HF response to geomagnetic storms and some things like that. So so what I would do is I'd suggest that we cancel this one in favor of letting everybody have the opportunity to attend Contest University if they like that day. And they've been very supportive. Tim Duffy has been very supportive of us so far, and I think it looks like a really good workshop. So I'm going to send that information out to the HamSCI listserv a little bit later, or you can go to CTU or contestuniversity.com and get that information.
We still have the meeting on the 30th?
Yes, so on the 30th, I think we do have the meeting. But I think, as I said, it'd be nice to be able to get a little bit more formal science done. So I know Diego's planning on giving a presentation that day. And maybe we can also have Steve Serwin give a presentation that day. Each of you would do 15 to 20 minute presentation. Then we have about 10 to 15 minutes for questions. How does that sound?
That sounds good. One thing to interject real quick. Do we have any plans for the frequency measuring test? Because that's in a week.
Ooh.
Oh, I don't. But go ahead. We can talk about it.
Yeah, I forgot to mention that.
Well, I thought that Gareth had mentioned wanting to do something with it, but I'm not sure entirely what.
I think that would be a really excellent thing for this group to do. We should all enter the frequency measuring test. It will be a week from this evening, I think.
I think that's a great idea. Christina and David, if you want to work on promoting that a little bit more, you're welcome to do that on the listserv, or we can talk about, or you can write something up for the website as well.
Okay, but briefly, everybody put on your calendar 10 o'clock Eastern time, a week from this Thursday evening, April 23rd.
Which 10 o'clock?
10 o'clock Eastern time.
10 p.m.?
10 p.m.
10
Eastern
p.m.
time.
Okay.
Only 2 frequencies this trip, 40 meters and 80 meters.
That sounds really good.
It's fun.
Yeah.
And that's broadcast from where?
Oklahoma.
Oh, okay. Good luck on the East Coast.
Yeah, we can.
Steve Serwin, are you good for giving a presentation the next Telecon?
That's in 2 weeks?
Yeah.
Yes. I say,
Okay.
tongue in cheek.
Okay.
I got a lot to do, but I'll try and I want to get some more data.
Okay. And I mean, if you want to postpone it, you know, we will have Diego to talk to, and there will be other things to talk to. So if you'd rather do it, you know, say more around the end of May, that would be fine too.
Okay, I'll let you know if I can't make it.
Okay. So you can let me know. So you're a tentative yes, and Diego is a more definite yes, right?
Correct.
Okay. That sounds great. And last thing, I know we only have a couple more minutes. Bill, did you want to talk any more about selecting with Scotty about channels and bandwidth for the Tangerine SDR?
Yes, because this is of interest to everyone in this group, I think. We've been talking about, I don't know if you followed the discussion in the mailing list, but we're talking about trying to find the right trade-off between the width of a channel that you monitor and the precision of how closely you monitor it, and the frequency of getting measurements, because they seem to all be tightly tied together. And not having any other guidance, I said, well, what if we wanted to get something where you could measure, say, plus or minus 50, 500 millihertz, you know, half a hertz in either direction from the carrier frequency, and down to a precision of 10 millihertz. So now that the calculations that were done with the sampling rate we're going to be running, that means you're going to have 102 seconds for each measurement due to decimation rates and so forth. So I guess the question is that the right amount of, is that the, I'm just pulling this out of the air. I mean, somebody needs to tell us if this is not the best trade-off between how frequently you get the measurement, how precise it is, and how wide you can measure. Where we're anticipating we're going to run simultaneous measurements on 8 channels. That is WWV on 2.5, 5, 10, 15, and 20, and CHU on 3, 7, and 14. So, so somebody in the science community needs to think about, is 500 millihertz away from the carrier as far as a range, is that sufficient? Because Steve Serwin's display seemed to show some stuff that was further away from the carrier than that.
Yeah, we're seeing in our WWV stuff with the simple radio between 0.5 and 0.75 hertz deviation.
And occasionally more than a hertz, but only occasionally.
Only occasionally, but 0.01 hertz is the resolution we're shooting for.
10 millihertz.
10 millihertz.
Same thing.
Yes.
Well,
and then how frequently are you getting your measurements?
We are not using the same technique that you are. We're using a nonlinear technique.
Oh, right.
We're using 1 second epochs and doing a statistical process to get the better resolution. It's true, a linear technique does it exactly as you're describing, but keep in mind you'll be getting an average frequency over that period.
Right. So I guess this is a question for Nathaniel and whoever wants to use this data for science purposes. We need some guidance on selecting this. And also, I guess maybe I need to have a detailed discussion, a sidebar with Scotty at some point to talk about how it sounds like we've got more than just two settings. I mean, there's the center frequency and then there's the bandwidth. And
Right.
Maybe we need also to specify the sample rate, and then the DE can select what the decimation should be to suit that, or somebody else tell me, because this is not really my specialty, this digital signal processing.
Well, what I was figuring was going to happen was that you're going to tell the data engine what kind of sample rate you want.
Yes.
And you're going to get a corresponding bandwidth that is reasonable for that sample rate, because there can be a lot of unreasonable bandwidths for a particular sample rate that we don't want to bother with. So you pick a sample rate and you get a reasonable bandwidth, and then that's the data that you get. And if you want different ones, let's make sure that we implement the ones that you're going to need in the data engine.
Well, as we discussed we went back and forth a little bit about this on the mailing list. Since we're only looking to collect data that's maybe 1 or 2 hertz wide, it would be better if the data that we don't need for that is dropped without being sent across the wire, so I don't have to do all that processing in the small board computer.
Yeah.
Right. So you get a virtual receiver for every carrier you want to measure, and then we downsample it down to 100 hertz or 10 hertz or some very low rate. But that's assuming that you want to use the technique that you're talking about that averages over 100 seconds. That may not be acceptable for what David wants to do with his linear method. And I don't know what kind of data you need, what amount of it you need, David, to do what you're doing.
Well, we are using a nonlinear method.
Nonlinear method.
Why could we not use the method that David's using, but also use that same method on the Tangerine?
I am inclined to agree, actually. I think the 100-second resolution is going to be awfully smeary.
Problem with that is it varies so much within that 100 seconds, it's going to be all over the place.
Well, I think it's the opposite. You'll lose all the interesting features.
Yeah, that too, because it averages it.
So then, David, your algorithm is in the time domain, right?
You can't really make that statement. It's a frequency domain method in the sense that it's a frequency estimation method. But as the group of us have been discussing, there's a fair-sized literature of the statistics of frequency estimation in noise. In using a sampled system, well, yes, it often uses Fourier transform, but that doesn't tell the whole story. Fourier transform is a linear method. The statistical methods, the frequency estimation in noise methods, are nonlinear.
Okay, so as far as what I would have to give you as the data engine for data, I would give you IQ data. What kind of frequency bandwidth do you need to do calculations? I don't.
It can be pretty narrow. You need it to include the frequency band that you expect to find the signal in. So, for example, the nominal frequency plus or minus 5 hertz at absolute most, and what you might need for frequency spillage, maybe another couple of hertz around. You don't need very many bins.
Okay, but I'm going to give you time domain data. So if you want bins, you're going to have to do an FFT, which means you're going to have to take, if I give you a really low data rate, it's going to take a lot of samples.
Yeah, we're sampling at 8 kilohertz right now.
Okay, so if I were to give you 8 kilohertz of IQ data, that would be sufficient?
Once per second, yeah.
As long as the input to that is adequately band limited, yes.
Okay, and yeah, I can do that. I can band limit the input.
Yeah.
So
that's what it amounts to. That's correct.
Yeah, because see that for the FPGA, so for instance, if I was to give you 8 kilohertz IQ data, and then you wanted me to band limit it to 5 hertz, That's hard.
Well, even if you band limit it to 3 kilohertz, you're fine.
Okay, now that's doable.
That's the basis of this, is doing it at baseband, in fact. So the band limiting is 0 to 3,000 hertz. But it may be easier for you to band limit it at 3,000 hertz centered on the signal. You're not doing this at baseband.
I can convert it to baseband. That's
in
what
that case, it's much easier.
Yeah.
And
So if you only need 3 kilohertz, though, is there an advantage to me giving you 8 kilosamples per second, and band limiting it to 3 kilohertz? You give you 3 kilohertz band limited.
If you band limit it tighter, then you're correct. You don't need as high sampling rate. You still need a second of samples. And to prevent aliasing, the band limiting has to be really good.
Right. And that's that we do in the FPGA is we have match the band limiting to the sample rate, because, and like I said in the email on the list, if I'm going to send you 8 kilosamples per second, if I band limit it to anything above 8, then you're going to see a bunch of garbage folding back into your baseband that you don't want to see, right?
Correct. Actually, if you band limit it above 4, you will.
Well, I'm thinking of 8 I and Q. So really you're...
Yes, I understand.
Yeah, so that's why we kind of pair it up together, because if I don't want to really, I don't want the band with I want to band limit the data to something less than the Nyquist band, but I don't want to really go way overboard with it and limit it down to 5 or 10 hertz and give you 8K, and basically I'm giving an oversample signal then. And that's harder for me because I got to make sure that between 5 hertz and say 4 kilohertz, there's no signals. I have to filter all that out, and that's difficult. But if you do that in your algorithm, then that works. I can give you 8 kilohertz band limited to 4 kilohertz. That's easy.
Nathaniel, do we have our library of frequency estimation papers uploaded where everybody can get at it?
I don't know that. I don't think so.
We have a repository site like a Google Drive for such things.
We do have some Google Drives running around. Everything's not nearly as centralized as you might like it to be.
All right, on ours at Case, we have a folder of these papers, and the key one is a 2006 Australian paper that the FL Digi analysis code was written around. We have spent quite a bit of time discussing this paper among ourselves, making sure everyone understands it. And Skylar Danhoff, who's not on this trip, is preparing a Python version of it. She and I spent time earlier today reviewing her code.
Can you send me a link to that or a copy of it?
Sure.
I'd like to see that as well.
Well, I don't mind emailing it to anyone who wants it, but if there's a repository site, everybody can get at it.
Yeah. Can you just share your Google Drive? I mean, with papers like this, you don't necessarily, if they are the papers that you have posted, are they behind a paywall normally?
I don't know how to answer that. Christina?
Basically, we can't be in a situation where we are posting publicly papers that are not already publicly available. So
I don't think
I think a couple of them might be, but I couldn't answer that offhand.
Yeah, we're probably safer, just sharing them to the people as needed, I think.
I don't think I took these from anywhere where I shouldn't have taken them, if that's what you're asking me.
No, I'm not saying that.
Did you take any from IEEE Explorer or something?
Yeah.
Well, one way you can do that that's fairly safe is to just provide the citation to it, and those of us, which is most of us, who have access through their university because it's paid for by the university anyway, can go get them that way behind the paywall, and everything is up on the up and up. That's another way to.
I'll tell you what. I will type the main citation into the chat box right now.
That sounds good.
That'll work.
But for Scotty's reference, what we are doing with the very simple station that I've been running is basically running at a standard 8 kilohertz input and running it through this algorithm on a 1 second epoch, and it's spitting out the resolution of 0.01 hertz of the carrier, which is the 1 kilohertz offset from the main carrier the way we're running it.
And you get an update every second?
We get an update every second, yes.
Okay. Yeah, because I'm not with the university, so I can't get stuff behind paywall. So it would be interesting to see that algorithm. But all I really need to know is what data you need to get from me to
make
your algorithm work.
And the thing that's interesting about this algorithm is it's an iterative thing, but they've shown that 99% of the time, after 2 iterations, you're dead nuts right on the money. So it's very, very efficient.
That statement's not quite correct. You're as good as it can get.
Good as it can get, yeah.
If the signal is down in the noise, it won't get any better than it can get.
But it's not like it has to loop 100 times to get there.
That's correct.
Yeah.
Yeah.
Well, we also need to sort of decide how to specify this in a channel configuration.
Yeah.
So, and like I read, Bill, I read your email. And it sounded like the way you specified it was good. And all we have to do is make sure that, for instance, 8K sample per second is an acceptable data rate. It's one of the ones that you can pick. And so that satisfies their requirement.
Yeah, I'm thinking 8192 and not an even 8 kilohertz. So
right. 8192, yeah. And something roughly between 4 and 6 kilohertz of bandwidth.
Yeah, we're limiting ours. It's being limited to 3 kilohertz just by the way the ADDs are working, the USB dongles. So you see it cuts right off at 3 kilohertz. So
we can do that.
So that should be easy enough for you to be able to do.
Yeah.
But
everyone, I need
to know
to
what we need, though. I agree. Yeah, we need to get that information to you.
I need to run because I'm giving a talk at 4:30.
Okay.
So, but you can keep talking, and because I'm not using the Zoom account for that 4:30 call. So I actually made a bunch of you co-hosts. So when you're done, it should automatically stop the recording, and I'll be able to post the recording later. Does it sound good?
Yes.
All right. So thank you very much. Sorry I can't stay longer, but this has been really good.
Thanks, Nathaniel.
You're welcome.
Nathaniel.
Thank you, Nathaniel. Take care.
Talk to you soon.
Yeah, we'll be in touch. Well, so Scotty, so the channel configuration layout specifies a center frequency in megahertz and a channel bandwidth in kilohertz. But it sounds like from what we're saying here, maybe it's not channel bandwidth, it's sample rate.
Sample rate, yeah, and then we'll adjust the bandwidth to match the sample rate.
So the sample rate should be like an integer, not a floating point, or should it?
And it should be a power of 2, preferably.
Yeah.
Like 92, 16, 384, whatever, because actually I guess that's not really true, because what we do is right now we do 192 kilosamples per second, 96 kilosamples, 48 kilosamples. So it is 48,000. Okay, it's not a power of 2. It's a number, and the reason we do that is because this dates back to the sound card days when those were common sample rates for sound cards, and so we made them the same. So
yeah, 48 kilohertz and then the 44.1.
Right, and we never did anything below 48K, so it was 48K, but we can certainly do 24K or 12K or 6K or 8K. I mean, we can do whatever is necessary, and that's why I wanted to leave the command kind of open. So one of the legal, we'll just make a legal sample rate 8K or 8192, whichever you want.
No, don't do that. There are historical reasons for it, but every sound card out there will have as a native rate 8K. It won't have 8196.
So it's 8,000.
Correct. So just do 0 padding if you want to do the FM.
Okay. And actually,
guys,
to making them multiples of each other, because the filtering scales. So as you increase the data rate, you increase the filter bandwidth, and you can end up using the same filter with the same coefficients on multiple sample rates. And it's very nice.
Can I interject something before I split, please?
Yeah.
From the data that I've seen, just about any morning, you can see positive frequency excursions at dawn that go maybe 1.8 hertz on a peak. Rarely as in one time, I saw several sidebands that were 3 hertz away, which corresponds to like a 240 mile an hour velocity, Doppler velocity. But that only happened once. And I don't know, maybe it was something involving the jet stream that's consistent with those velocities. They don't go that far in the negative direction because the evening recovery for the ionosphere is a lot more gentle. But usually all my data is taken plus or minus 5 hertz. And typically on a typical morning, you'll see stuff out to a hertz all the time and a few excursions up to 1.8 or 2.
There actually is a high level jet stream up in the ionosphere, as well as our tropospheric or stratospheric jet stream.
Yeah, I looked into that a little bit and I saw a picture that showed swirls where it had vertical components that went up and down, which are very relevant to radio propagation.
Like vertical shear?
Yeah.
That kind of thing?
Vertical winds, yeah.
Does anybody know of anything that's been going on the past couple of days? Yesterday's 10-meter whisper data showed just incredible propagation across North America.
6 meters has been open the last 2 days.
Yeah,
6 to 10
I work
have been
stations
open.
all over South America, all over North and South America, both on 6 meters. Yesterday and the day before.
Yeah, I've been following 10. Must be the same thing.
Yep.
Yeah.
I was listening to 6 the other night.
Yeah, the reason I recognized it was open, I started hearing the squelch open on a local 2-meter repeater, and normally when if I hear that, it means that 6 meters is open.
You know, the way they used to do it not that many years ago was that the guys that wanted to operate VHF-DX would turn a TV onto a TV channel that wasn't in their city, but was several hundred miles away. And when they started to see a picture come in, it's time to go turn on the radio.
Yeah, really?
Yeah, unfortunately, we've lost those sounders.
For us here in Cleveland, it used to be if the television station weather radar showed the north coast of Lake Erie, the Canadian coast.
Oh, you're looking at range of a weather radar? That's a cool way to do it.
Yeah.
Well, so as far as finalizing, for this iteration of it, finalizing what goes into the channel configuration, are we fine? Scotty, are you happy that if I provide a center bandwidth in megahertz and a sample rate as an integer, typically being 8 kilohertz, that there'll be a standard way that you can sample and provide at that rate, so that I have this approximately this range of measurements to work with for this analysis?
Well, I think I'd rather have you, well, I'm not sure. I guess it doesn't really matter. The thing is that you're not going to be able to just give me any old data rate.
I understand. I know.
So,
yeah. I mean,
so it's almost you either can pick it out of a table and say, here's the numbers, here's 8 different data rates, and here, give me a number from 0 to 7, and that'll be a valid data rate. Or you can give me the data rate, and I can compare it. And if you ask me for something that is, like if you ask me for 9 kilohertz, you'll just get a knack back. I can't do it, so you get it.
Yeah.
But that leaves me having to guess what it is that I do support.
Well, I mean, once it's programmed, that's what it, I mean, that's setting the clock, though, isn't it? Is that a clock setting, or?
Well, this would be a data stream parameter. Okay, so you'd say, okay, now I want to go to this A to D, and I want the data this way. I want it this speed. I want decimated. But when you give me the sample rate, that tells me how much I have to decimate. The sample rate, the incoming data sample rate is fixed by the crystal oscillator. So if you tell me I want it 8,000, then I know exactly how much I have to decimate by. So, but it's not free form, so I can't, because the filters don't scale like that necessarily. If you ask me for something that I can't do, then It's not like it's not all parameterized, I guess is what I'm getting to.
Yeah.
Going to have to be designed for certain sample rates. So we'll be able to implement certain sample rates. And if you want a different one, we can add that, but it can't be determined. All of them can't be determined on the fly. I'm not being very clear here, but you can't
Well,
just
you know,
number in and have the filter decimate by that much. I have to know ahead of time what decimation values you want me to implement, and they're discrete. So
well, here's a thought. What if we designed a little inquiry where I send you something, a B with a question mark or something, and then you give me a table indicating a number and a supported sample rate, and then I'll give you back that number to pick the one out of the table. How would that be?
That would be good. In fact, this fits in kind of with the HPSDR, the dream that they had for querying hardware about what its capabilities are, is to give you back an XML file that says, here's the capabilities. But, let's start simple and say, well, what capabilities do you need to be defined? I mean, the frequency of the sample rate's already determined, 122.88 megahertz. That's in the hardware. So let's not worry about that, but you can have a command that says, give me a table of sample rates that you can provide. And then I give it back to you in a certain format, and you can pick one of those. That's what you're talking about, right?
I think so. I'll send you an inquiry, and then you send me back a table, and then I get to pick from the table.
Right.
I'll tell you.
We can add additional commands if you want to know other things like, how many ADDs do I have? How many antennas do I have? I mean, specific hardware questions, and we can build on those when you need them.
What I have running in the simulator so far is just a status. Any one, all of the commands are 2 bytes, with the second one being a question mark if it's an inquiry. So S with a question mark is a status inquiry, and you just send back something, an ACK or an OK. So I know that the data engine is alive. And then maybe a B with a question mark behind it would be bandwidth or speed or something that indicates I want you to send me the table.
And all of these, since they're on the command side, are all going to be either ACT or NACT.
When we turn on data collection, you're not going to act that, are you? You're just going to start sending data.
The data stream you don't, but the commands you do.
Yeah. Okay.
Yeah.
Well, what I mean is, I'll send you a command to start sending data. So the question is, are you going to act that, or are you just going to start sending data?
I'm going to act that, because if you have set up some illegal format, then you get a NAC back to that. But once I turn the UDP data packets, nobody's going to ACK or NAC those. Right? The data stream's not going to have any ACK or NAC on it. But everything that changes the configuration or starts or stops, those all should be ACT or NACT.
Okay. All right. All right.
So therefore, everything, it's sort of like poor man's TCP/IP, right? But we don't want to do TCP/IP, so it's UDP with one level added on for acknowledgement. No repeating of packets or anything like that. It's just a simple, I understood that, I can do it, or forget it, you asked for something I can't do. Or, of course, no response if the packet gets dropped somehow.
Yeah, and what I was hoping we could do is, for those things where you can determine what the error was, the NAC should have an error code with it. And then, so some kinds of errors that you detect, a NAC with a 1 byte, 1 or 2 bytes, it indicates a code which we can look up at a table and know what we did wrong.
Yeah. And what I was thinking is you could almost do it like, if you send a NAC back, you could, in the NAC command, you could tell the user what he actually got. So if you asked for 9K, you would send a NAC back saying, well, I sent it to 8K because that's the nearest one I could find. So,
well, if all I'm doing is sending you an integer that indicates the offset in the table, the only error was if I sent you an integer that wasn't even on the table.
Right. So, I'm trying to make it too complex.
Yeah.
But you just like to know why it is that you're not getting what you want.
If, you know, in those cases where there's multiple possibilities of screwing it up, we like to tease them apart, because, you know, you detected something that was wrong. So what was it? You shouldn't have to guess that.
Instead of just saying -1 error, you know, you want to know what it is.
Yeah, in those cases where it's possible to determine what the error was, sure.
Yeah.
Yeah. All right. Well, okay. Well, I'm going to have to study on this a little bit further. As you know, I'm a neophyte in the digital sample stuff. So, but we get it figured out.
Okay. Sounds good.
All right. Thank you.
You're welcome.
I think that might be all we had.
I want to make sure John got the link to the part for the I2C. I put it there at the very beginning in the chat window. I put a DigiKey link and a part number.
Got it.
Okay.
Yeah, and I was interested, so I got it too. Thanks.
Thank you.
You're welcome.
Perfect. And do we want to collaborate at all on this, Scotty, for the development of that board? It sounds, because I have to put one of the magnetometers on my system as well.
Yeah, and you're going to want to put it on a system with without a data engine to start with, right?
Correct. I'll have a Raspberry Pi to talk to it, but that'll be it.
So here's what I'm thinking, and this may be heresy, especially for all the work that Dave's done, but he's done all the groundwork. What I'm thinking is that I'm going to change Dave's board around a little bit to be a Raspberry Pi hat with a PMOD connector on it.
Okay.
So that we can plug it in using the PMOD connector into the data engine in the future. But right now, people are going to be using Raspberry Pis or Odroids or something. So I'm going to make it so it plugs right onto the top of the Raspberry Pi as a remote board. As a remote, it's the local half of the local remote.
Right.
And then you take the same board, plug the magnetometer on it, and plug the Cat5 cable in between the two boards. And now, bingo, you got a system with no data engine, but a Raspberry Pi or Odroid, or single board computer, and a remote magnetometer.
Okay.
Excellent.
Can I bother you to get schematics for that?
Yeah, as soon as I get them done.
Okay.
I'm really building on Dave's work because he's done all of the groundwork of what's going to work and what's not going to work.
Okay.
And I'm going to kind of pull the pieces off and morph it into a Raspberry Pi board. That was my thought.
Okay.
And been working over in my head, because that way, for people who don't have a data engine, but have a Raspberry Pi, and this is going to be all of the users to start with, they can just plug it right on, and they're on the air, ready to go.
Well, my whole science weather station is going to be a hat for the Pi, because I'm going to be providing power for the Pi and everything on it. So this is going to be just another module that gets put on there. So that's why I was.
Yep.
Yeah.
And our current research system is Raspberry Pi as well, so that'd be great.
Okay.
Yeah, so it'd be just a general single board computer hat that would work. And then when we get ready to put it onto the data engine, we'll just plug it into the PMOD. And actually, we're going to have a Raspberry Pi hat on the data engine, so we could maybe plug it right in there too. So it could go either way.
And this David as N1HAC is the correct David to talk to?
Yeah.
No, David.
No, the other David.
The other David, KD0EAG, Dave Witten.
Okay, KD0.
Yeah, he's dropped off.
Echo Alpha Golf.
Kilo Delta 0 Echo Alpha Golf.
Right.
Got it.
He's on the mailing list, and he is on the TeamSpeak pretty much every Monday night.
Okay. Got it.
Yeah, he's done all of the groundwork for that. He's got boards working and talking 100 feet away. And
he definitely is somebody I need to talk to then.
Yes.
Okay. Excellent.
And you got the part number of the sensor we're going to use, right?
Yeah, I actually ordered 10 of them.
Yeah. Okay.
I have them sitting on my bench.
And you got the little $20 boards, right?
Yes. Yes.
Those are the exact boards we're going to use as plug-in to the module.
I can't understand why they charge $40 more per board for the two headers. That makes no sense. But I'm not asking questions.
Pretty crazy.
Well, so you bought 10 at a time and they didn't balk, right?
Nope. They charged me $25 shipping, because I originally was going to order 5. It didn't matter how many I ordered. The shipping was $25. I said, okay, give me 10 of them.
Wow. Okay. So for $225, you got 10 of them then.
Yeah.
Okay, that's good, because I was, a lot of times when companies make up development boards, they don't want to to use them in a production environment because they're loss leaders. So they'll sell you 1 or 2 or 5, but when you go and I wonder what's going to happen when we go to buy 100 of them. What are they going to do? Are they going to
might have to get 10 people ordering 10 each?
Yeah, yeah. We have to get the mail chain going. And
yep, there's ways around it.
Yeah.
And there's a run on these things somehow. For some reason, everybody's developing these things. How did that happen?
We're going to include a roll of toilet paper with each one.
Yeah, around here, that's the rationalization for why the gun shops are all still open, because you need to buy guns and ammo in order to be able to guard your great store of toilet paper.
Well, did you hear? They say when you sneeze, you're supposed to sneeze into your elbow, right? So
yeah, that's what they say.
All right. Well, this is proof that if everybody's buying toilet paper, it's just proof that none of these people know their ass from their elbow.
Yeah, that could be said of a certain administration too, but we won't go there.
Yeah, really. I'm actually enjoying the sequestration because it's like I don't really need to talk to many people. It's like, this is fine, you know. You get to talk to the people you want to talk to, and then pretty much everyone else you can stay away from, and now you have an excuse.
Works for me.
Yeah, earlier I was saying that was the greatest thing for FT8, allows you to make QSOs without having to actually talk to anybody. So for us super introverts like myself, it's perfect.
Like my buddy says, I can sit here and I can play solitaire while I'm making QSOs.
That's right. Mm-hmm. Or you can be on a telco with your boss while you're making QSOs. I mean,
don't share the screen.
That's right. Don't accidentally share it. Well, what was
you don't even have to be there.
There was
I've had my machine make QSOs for me, and I didn't even know it.
Well, I remember there was a program that I had, a game program that I had, that had a boss key.
Yes. Yeah.
Like F1, and it would bring up a spreadsheet.
Yes.
You know?
Right. I've seen that. Yeah.
I remember that.
Lotus 1, 2, 3.
Was that a Lotus?
Yeah, it was for Lotus.
Okay. Oh well.
Back.
All right.
All right.
We will see you guys. Enjoyed it.
Yeah.
All right.
Keep in touch.
Thanks again. Good meeting. Take care.
Thanks. Later.
Bye, everyone.
Bye now.